So moving on to number 7, it says the first two terms of an arithmetic progression are 16 and 24. Find the least number of terms of the progression which must be taken for their sum to exceed 20,000. And we are told the first two terms, meaning we have 16 and 24, like that, right? And this is our first term, so we can call it A, and this is our second term. And we can get the common difference. The common difference, since we know an arithmetic progression is what we call a common difference. So get that by saying the second term 24 minus the first term, which is 16, and it gives us 8. So I have D equaling to 8 and A being 16. A is 16, D is 8, right? And we're going to be using the formula which says Sn n over 2, then 2a plus n minus 1 d. You can also get this formula from your MF19, which is provided in the exam. So we are trying to find n, right? For which it says find the least number of terms of progression which must be taken for their sum to exceed 20,000. So sum should exceed 20,000. So we're saying n over 2, 2a plus n minus 1 d, right, should exceed 20,000. We're looking for the n value where this expression exceeds 20,000, right? So it's n over 2, and our 2a will be 2 times 16, which will give us 32, plus our n minus 1, our d is 8, right, being greater than 20,000, like that. And so we can multiply both sides by 2. We can multiply both sides by 2, right? So having done that, we'll get n 32 plus 8n minus 8 being greater than 40,000, right? Then this will come down to 32n plus 8n squared minus 8n being greater than 40,000, right? So 8n squared plus 24n minus 40,000 will be greater than 0, like that. Then we divide everything by 8, right? We're surely going to get n squared plus 3n minus 5,000 greater than 0, right? Then we use our quadratic equation, right? So we're going to say n is equals to minus 3 plus or minus root of 3 squared, which is 9, minus 4, a, which is 1, c minus 5,000, right, over 2a, which is just 2. And this is going to give us two values of n, right? Let me just punch this in my calculator. It's minus 3 plus root of 9 minus 4 times minus 5,000 over 2 give me 69.226, or let me change this to a minus, give me minus 72. And we know for a fact that our n cannot be negative, so we're taking this, right? We're taking our n to be 69.226, and we can always round this to give us 70. So our n is 70 because we want a whole number, so rounding it we get 70. So that's it for part A, number 7. Moving on to part B, it says a geometric progression is a first term of 6, It is the first term of 6. This is a different color. It is the first term of 6, right? And the sum to infinity. Sum to infinity of 18, right? A new geometric progression is formed by squaring each of the terms of the original progression. So the a for the new item will be 6 squared, that will be 36, right? Then find the sum to infinity of the new progression. Find the sum to infinity of the new progression. So firstly, we're going to get the common ratio of the first progression. And we know the formula for sum to infinity is equals to a over 1 minus r, right? And we're told that the sum to infinity is 18 and our a is 6 over 1 minus r. So we cross multiply, we get 18, 1 minus r is equals to 6. So 18 minus 18 r is equals to 6. This will give us 12 is equals to 18r, and r equaling 12 over 18, which is as good as 2/3. So if the r value for the first progression is 2/3, then surely the r value for the second one will be 2 over 3 squared, like that, right? So it will be 4 over 9, right? Using that now, we know we are still going to use the same formula, a over 1 minus r, and we know our first term for the new one is 36 over our 1 minus our r, our new r, which is 4 over 9, right? And this is going to give us 36 over 1 minus 4 over 9, 36 over 1 minus 4 over 9, that's 64.8, and that will be our answer right there, right? And that's it for number 7. And for our new syllabus, we won't be covering vectors as part of our P1, so we're going to skip that number 8.